Today we are not gonna deal with wires, but instead spend some time watching animations. It's gonna be a video with some more theory in it. I know, theory is boring, but I really need this video in order to explain all of my further videos with it. The theory in these 5 minutes is so important that it covers nearly 90% of the theory of all of the applied electricity. Here I'm gonna give you the basics of electricity, how it works, how it's organized, and what are the main characters. I'll keep it simple, short, and at the point. I promise. Let's go. First, we start with the electrical circuit. Everything in electricity works in circuits. In order for the bulb to light, there must be a closed electrical circuit through which the electrical energy to flow. A circuit has three main elements. First, it is the power source. Then there must be a consumer, and finally there must be electrical wires that connect the electrical source and the consumer in a circuit. The power source could be the electrical grid or a battery. The consumer could be anything from a light bulb to an oven. The consumer is also known as electrical charge. Of course, there could be plenty of other elements. Let's add here a switch, for example. Now, the power source generates power. It applies electrical tension to the circuit, which is marked with the letter V. The unit for electrical tension is volt, after the Italian Alessandro Volta. The applied tension creates an electrical current that starts flowing through the circuit. The current is marked with the letter I and is measured in amperes, after the French physicist André-Marie Ampère. Finally, the electrical charge has some form of electrical resistance. The unit is named after the German physicist Georg Ohm and is measured in ohms. Meaning all of that, Georg Ohm formulated his law of Ohm a couple of centuries ago, and since then, the electricity has never been the same. Here is the main formula of the law of Ohm. The current equals the tension divided by the resistance. Then the tension equals the current times the resistance. And finally, the resistance equals the tension divided by the current. Here you can see an easy way to express any of the elements. You simply put your finger on the quantity you want to know, and you see right away the relation between the other two. Then it comes the power. The power is measured in watts after the famous British inventor James Watt. Power could be marked as P, mainly in Europe, and W in the United States. No matter the letter, the power is the result of the multiplication of the electrical tension and the electrical current. Finally, the energy is the multiplication of the power and the time this power has been consumed. It is measured in watts per hour or some of the bigger units for power, kilowatt per hour or megawatt per hour. And that's all. All of the electrical values revolve around those 5 electrical quantities. Again, I'm gonna use this video a lot later in order to explain things we do in electricity and we don't do. That was all for today, folks. Take care.